Welcome back to the TrueGrid Introductory Training Course. In this lesson, we will learn the basics of importing and saving our data. We will set our working directory. We will start TrueGrid without a file. We'll introduce you to the menus. We'll show you how to use a dialog box to write a command. We'll type commands directly into the text box. We'll copy commands from an existing TG file. We'll open an existing TG work file. We'll read in IGES surface CAD files. We'll copy commands from a manual, read in element and coordinate files, show you where your tsave files are saved, use the save command, and we'll help you understand the 3 tsave files and how they're used. Go to your TrueGrid directory and open the Utilities folder. Here you will find a utility program that allows you to control your user preferences, called tgpref. It's the file with the little yellow steering wheel icon. Alternatively, it will pop up in your program search bar when you type TrueGrid. Here we see TrueGrid controls. This is where you will set your working directory. Your working directory is where you will retrieve and save your data files while you're working in TrueGrid. You can change your working directory anytime you wish to. From here, you can browse and select a different working directory. It's critical that your user has read-write authority in your working directory, or TrueGrid will not run. Anytime you want to pull a file into TrueGrid, you will need to save it in your working directory. The tsave session files created by your TrueGrid session will be saved in your working directory by default. Now let's start TrueGrid.
Now when you run TrueGrid, one of the first things you'll notice is this window pops up. It's a console window. And one of the things it gives you is the version number, and it gives a date of when it was compiled. And then a second window pops up. Well, this window is showing us all of the .tg files that are in that working directory. So I could select one of them and click on Open. But in this case, I don't want to use an existing command file. I want to start with a fresh slate. So I click on Cancel, and that puts me into the control phase. This is the text window, and these are the different categories of commands. For instance, output. You would define steps under the analysis. So if you clicked on analysis, for example, what happens is the list of menus was removed, and in place of it are a list of keyword commands under the category of analysis. And so, for example, we could click on Abacus step and use this dialog box to select different options associated with the analysis. And once you're finished selecting features here, you then would click on Execute and Quit. Now, the dialog box has two basic ways of presenting the material that's in the dialog. You'll see on the left-hand side here, there's a right arrow. When you see that, it means that each one of these options, and each one is an option, is mutually exclusive. So for example, if I were going to choose to do frequency analysis, I would click on it, and what you would see is all the rest of them were removed. That's one of the characteristics of a mutually exclusive list of options. And in its place, we have the option I selected, frequency. It's highlighted in yellow. And then there are some additional parameters to be specified under the frequency option. One of them would be the number of eigenvalues, and another would be the maximum frequency. Plus these additional options, which we can click on if we want. Now that introduces to us a second type of option, and that list of options is also optional, but they're not mutually exclusive. So I could select the shift point and the number of vectors, and if I wanted to, the number of iterations. And in each case, for this particular set of options, one number is required for each one of the selections. Now, if you go to a point where you say, I didn't really want the number of iterations, that yellow string of characters, just click on it and it toggles it off. Because if you toggle it on so that there's a green box here, TrueGrid requires that you supply a number. So if you decide you don't want the number of iterations to be specified, click on the yellow to turn it back to white. And it's an amazing collection of features that can be displayed and chosen and acted on by using these simple mechanisms. Now, once you have finished what you wanted to do in this menu, you can click on Main Menu, and I'll choose a different command this time. I'll go back to the main menu and I'll go to velocity and acceleration. Now, in the control phase, it's not very much. We have just two options. So if I click on one of them, let's say rotation, and I type in 1, 2, 3, and the enter key at each one of them. And just for the sake of explaining how this works, I'm purposely not going to specify the rotation, and I'm clicking on execute and quit. Notice that the field that was incomplete was brought to the top of the dialog box, and it's turned blue. This is your warning that you didn't finish the data. You need to finish it. So I'll put in 4, 5, 5, and 6. Oh, I got 56, but it doesn't matter. And once you've completed that list of parameters that are required, then you click on execute and quit. Now notice what happened. TrueGrid placed the data that was generated by the dialog box into the text window. There's a consistency here, and I want to explain all the consistencies. This is exactly what you'll see if you were to look at the tsave file. So one of the reasons for this being printed here is so that you know what's being put into the tsave file. But secondly, you don't need to use a dialog box. You can type the command in. So if I were going to type this in, I would do a rotation. I would type in rotation, and then I would put in the three coordinates, 2.2, 3.3, 4.4. Now, one of the features of inputting data is that if you don't finish with all of the arguments and you hit enter, it will prompt you for the next argument. Now, suppose you've come this far and you've decided, I don't want to do it this way. Just hit escape and it'll drop you out of that. And then you can go and do a different command, or maybe you need to use the dialog box instead of trying to do it by memory. This is true with all of the commands. You can type them in if you're confident enough, or use the dialog box. Now there's another feature I want to demonstrate, and that is dropping data into this window. So I'll open up the kpipe file with my favorite text editor, and then I will use the left mouse button to capture the text and tell it to copy that. Come over here to TrueGrid, move the mouse to this position here, and use the middle mouse button to paste. And the entire input file was executed that way. So I didn't even need an input file. Well, it's nice that you can go into an existing file, select some commands, and paste them into the text window. By the way, notice I lost my menus, so I hit enter to get them back.
Instead of opening TrueGrid in the control phase and starting from scratch, we can open an existing TrueGrid work file. Notice that the TrueGrid work files have the file extension .tg. Now, this is a large computational fluid dynamics mesh of the flows around an aircraft. You can also open a new session and import surface data from an IGES file that you've created in a CAD system. In TrueGrid, go to the CAD menu and then select IGES and browse to select your file. You'll notice TrueGrid counts as it reads in all of the parts. Enter the merge phase and then select Show All to see the image. Another way to bring data into TrueGrid is by copying the commands directly out of one of our resource manuals. Here's our examples manual. You highlight and copy the command lines into your buffer and return to the text box and right-click your mouse button to paste. You can also read in geometry files. We showed this in greater detail in our video named Projecting a Shell Mesh. Save your element and coordinate files in your working directory. In TrueGrid, enter the merge phase. Go to the CAD menu and select VPSD to convert viewpoint data to TrueGrid surface definitions. Name the surface, and then enter your file for coordinates, and then for elements. Select Draw to view your geometry.
When you assign a working directory, TrueGrid will create the tsave file in that working directory. This file is being written by the operating system, and it doesn't write things immediately. It saves up stuff to be written until it has a decent-sized buffer full of data. Then it writes it to disk. So if you want to look at what has transpired just recently, you may open the tsave file and see that it's empty or it's not up to date. So we have a solution for that. You type in save and it forces the buffer to be written out. So now the tsave file that was created in this session is up to date. If we go to the directory where I have my working directory, you'll see that not only do I have a tsave file, I have a tsave sharp and a tsave sharp sharp. Now, when you run TrueGrid, it creates a new tsave file, but it doesn't throw away the tsave file that was already there. It renames it as tsave sharp. But before it does that, it takes what it was the tsave sharp and renames it tsave sharp sharp. So we have three different tsave files here. This is the most recent and this is the oldest. So you have three chances to save your file by changing its name. If I wanted to use this tsave file in the future, I would rename it so that it doesn't get destroyed the next time I start up TrueGrid.